All right, for learning target 3, we're going to start to use what we've kind of learned in targets 1 and 2. We talked about functions and their inverses in targets 1 and 2. Well, the next two functions we're going to explore in this unit are exponential and logarithmic, and they are inverses. So the input becomes the output, and the output becomes the input. They kind of switch domain and range. We'll get a lot more into that tomorrow, into target 4. But for now, what does an exponential function look like? You've explored this in biology probably. Exponential growth and exponential decay, bacteria growing exponentially, growing really fast, right? Okay. So we're just going to graph and then talk about domain and range today, which makes this target pretty straightforward, pretty simple. We have complete control of the domain. We can plug in whatever number we want. We just chose to put in -4, -3, -2, -1, etc. in all these to keep it easy and simple, all right? So now let's actually do that. What do you get when you put, let's do an easy one first. What do you get when you put 3 to the 1? When you put 1 into that function, you get 3. So in the table, that's 3. What about 3 to the 2? It'd be 9, right? These are easy mental math problems, right? Let's go backwards. What's 3 to the 0? 1. Very good. Anything to the 0 power is 1. Now this is the not tricky one, but slow down and think just a little bit. What's 3 to the -1? 1/3. And honestly, that's what I want to see on your papers. 1/3. -2. 1/9. Yeah, you get, that's what I want to see, but I want to show you that if you take the calculator and graph 3 to the x and go to the table, that's not what you're going to see for -1 and -2 and -3. You're going to see decimals, but it's the same thing. Honestly, the fractions are easier to derive, easier to come up with, and probably even easier to work with, faster. So I don't care if you use the decimals or the fractions, okay, to get the picture, but you're going to see me work with fractions because it's just a little easier to do mental math. 3 to the -3 would be 1/27. And do we remember this one? 3 to the 4th, 81. Yeah, 1/81. So filling out the rest of the table here, 3 cubed would have been the 27, 3 to the 4th, 81. And this one, what about 3 to the 5th? There you go, good, 243. All right, so those are just a small sample of the points we could have picked. Agree? So let's graph the ones that we've got, and then we'll actually connect those dots, and I use that word, or use that phrase, not really willingly here, but you connect the dots to illustrate all the ones we could have found, but we didn't, right? All right, so first thing I would do, though, and some of you are already working ahead, and we're going to have to do a little erasing probably. If I'm going to graph these points, these numbers, I'm not going to count by 1. I'll count by 1 on the x-axis, but I'm not going to count by 1 on the y-axis. I'm going to change the y scale to something a little more conducive to graphing 3, 9, 27. Probably going to count by 3. At least count by 3. So that's what we'll do for this one. Count by 3. Now, the easiest point to graph would probably be the ordered pair 1, 3. It would be right 1 and up 1 if you're counting by 3. Right 1, up 1 if you're counting by 3. 2, 9 would be right 2 from the origin and up 3, 6, 9. And then 327 would be right 3, 1, 2, 3, and up 3, 6, 9, 12, 15, 18, 21, 24, 27, and that's going to be the last one that fits, right? Where is the next point to the right? It's at 481. In other words, it goes really far up. All right, now to the left. How do you graph 0, 1? You start at 0, and then you go up how far? About 1/3 of the way before you get to that first dash. The best you can do is something like that. Now, how do you graph -1, 1/3? Well, it's almost impossible to distinguish any of these fractions. It's almost 0. 1/3, 1/9, 1/27, they get closer and closer and closer to the number 0. And when you're actually graphing them, you can't really distinguish the dots. Your pencil lead's probably thicker than the dot needs to be, right? So you just do the best you can. This is -1, 1/3. This is -2, 1/9. -3, 1/27. You basically put the point as close to the x-axis as you can without touching it, right? And now, we'll cheat a little, take a look at the actual picture from the calculator, and our picture should model that one. So our picture gets big really fast once it gets over here into the positive x values. Would you call that growth or decay? Or you read a graph like you read a book from left to right. Is it getting bigger or small? It's getting bigger, so growth. Exponential growth. Domain. We only put -4 to 5 in, but what could we have put in that exponent? Anything. So all real numbers. What's the range? What comes out when you do? Ooh, so close. Yeah, this time it's only greater than 0 for this reason. Your fractions are 1 over 3, 1 over 9, 1 over 27, 1 over 81, 1 over 243, 1 over blah, blah, blah. It's always 1 over. It'll never be 0, right? We talked about this on Monday, called an asymptote. It tries to get to 0, but it never will. It's a horizontal asymptote at the x-axis or at y equals 0. We'll kind of put that together a little better at the end. But y is greater than 0 is the range. All right, and again, like I said, I'm going to do number 2 with you. Kind of pause the video and let you try number 3, and I may have to help with 4. But number 2, mental math. I don't want to use the calculator if I can avoid it. All right, so let's be careful. Let's take it slow. Let's pick an easy one first. Let's plug in 1/5 to the 0 power. What is anything, any number to the 0 power? 1. So 0, 1 is a point on this function, on this graph. Plug in 1/5 to the 1 power. 1/5. Now I think we can start doing a little mental math here. What's 1/5 squared? What's 1/5 to the 2? Oops, I need to keep my colors. 1 over, well, if I can pick the right color, 1 over 25. When you square that fraction, 1 over 25. When you cube it, 1 over 125. When you raise it to the 4th, 1 over 625. And then honestly, that's as far as I would know. I would not know what 5 to the 5th is. So I would have to take a little peek over here and yeah, do a little 5 to the 5th. It would be 3,125. So 1 over 3,125. All right, now let's go the other way. What would 1/5 to the -1 be? Think about that. What does a negative exponent do? Flips the fraction. Flips the fraction. So 5 over 1 to the 1 power. It's just 5. What does a -2 exponent do? Flips the fraction, 5 over 1, and squares it. So it becomes 25. -3, 125, -4, 625. You're getting the picture, right? What would be an appropriate scale to count by in this one, maybe? And this is a subjective question. You're going to graph the points 0, 1, -1, 5, -2, 25, -3, 125. You may say a scale of 10 or 15 or 25 or even 5. We'll keep it small for this one and do Y scale of 5. Not too many points are going to fit on the picture, but we will get the general picture. The easiest point to graph is probably which one? That one's easy, -2, 25. Left 2, up 5, 10, 15, 20, 25. And that means -1, 5 is probably also easy. -1, 5, left 1, up 5. 0, 1. 0, 1. That's x equals 0, and then up 1 would be like a fraction, right? Up 1 would be somewhere 1/5 of the way up to 5. 1/5 of the way. So we're almost into that fraction range. So how are we going to graph 1 1/5? A dot as close to the x-axis as you can get. 1 1/5, 2 and 1/25th, you get the picture, right? Now you graph from left to right. So where is this picture on the left-hand side? It's coming down, right? It's at -3, 125, which is way up there. And it comes down into the screen like this. And it's a smooth curve from there. Do the best you can, but that will never touch the x-axis. Okay, it's called an asymptote. It tries to get there, it just can't. So is that growth or decay? Getting smaller, so decay. What's the domain? All real numbers. And the range? It's still greater than 0. Now don't oversimplify the range and think it's always greater than 0. It will be. I'll go ahead and tell you, it will be. And even in all the homework problems, because I don't want to get this too confusing. I don't want to make this too confusing. So I'm going to stick with just positive numbers, and it will be. But I could easily throw a negative into the function and flip it upside down, and then it would be y. All right, but for this unit, our transformations, like shifting the function left, right, up, down, all that, we're going to stick to left and right on this unit, and left and right on this target, and up and down when we graph logarithms in target 5. Just to keep it simple. We could do the whole left, right, up, down with all of them, but I'm going to try it this way, and hopefully it works a little better. But I'll pause the video, and I want you to try number 3 on your own, and try number 4, but I'll go ahead and tell you, you're going to need the calculator's help. Mental math, I don't know what 2.5 squared is. Well, that one maybe. 2.5 to the, you're going to need the calculator and probably have to just use decimals. So give 3 and 4 a try. All right, you've had time to do number 3, so I'm going to start working it. And I'm going to put 0 in the exponent first. So 1/4 to the 0 power is 1. 1/4 to the power of 1, when I put x value 1 in, would be 1/4. When you square the 1/4, you get 1 over 16. When you cube the 1/4, you get 1 over 4 times 4 times 4, 1 over 64. And then the 4th power, what comes after 64? 256? 256, so 1 over 256. And 5th, I don't know that one. Thank you, 1 over 1024. I should have known that one. Your computer's working binary code, working base 2. So when you have a kilobyte, 1,000 bytes, it's not really 1,000 bytes. It's 1,024. It's an exponent of 2. Your computer only operates in on and off. Either you send electricity or you don't. 1 is on, 0 is off. Anyways, I digress. -1. Putting in -1, it flips the 1/4, becomes 4. -2 flips the fraction 1/4 and squares it. 16, 64, 256. We've already done all that back in our exponents work. What did you choose for your scale? 4, sounds good to me. So -1/4 is easy to graph. -2, 16 would be up 4, 8, 12, 16. Is 64 going to fit? 20, 24, 28, 32, 36, 40. No, so it's not going to fit. 0, 1 would be about there. 1/1/4 is now so close to the x-axis you can't distinguish. 1/1/4, 2 and 1/16, etc. So picture looks like that. Growth or decay? Decay. Domain. All real numbers. Range. Greater than 0. Feeling good? All right, the last one, which is a decimal, you're just going to have to bite the bullet and use the decimal. Okay? So I'll go ahead, for those who don't have a calculator, at least type it in and go to the table so you can get what you can out of this. Picture second table, starting at -4, so you'll be able to get several points from there to start with. Finish number 4, and then we'll wrap this up. All right, as you can see, we got the table filled out now. If you're going to graph 1 and 2.5, 2 and 6.25, 3 and 15-ish, 4 and 40-ish, what would be a good thing to count by? 10 would be okay. 5 would put something in that neighborhood, right? 5s or 10s or something like that. I'll count by 5. And then let's generalize what's going on with all these and wrap this up. You count by 5s. 1, 2.5 would be exactly right 1 and up half. 2, 6.25 would be right 2 and just a little bit above 5. 3, 15 would be right 3 up 5, 10, 15. 4, 39 would be right 4 and up 5, 10, 15, 20, 25, 30, 35, almost to 40. So it's pretty much impossible to distinguish between 39 and 40. And then that's the last one that fits to the right. On the left, 0, 1, 1.4, negative 1.4. Then you get into those decimals that you really can't distinguish. And then we've got our smooth curve, finishing that. Is that growth or decay? Growth. And domain, all real numbers. Range, again, greater than 0. So the generalization. What number for the base, the thing that's in the bottom, the base of number 1 was 3. The base was 3. What number is going to make growth every time? Can you generalize that? What kind of number is going to make growth? 3 or 2.5 gave you growth, so I mean it's only 2 problems. It's hard to generalize with just 2 questions. But what gave you decay? A fraction, 1/4 and 1/5. The generalization is if it's bigger than 1. If the base is bigger than 1, you're going to get growth. If the base is between 0 and 1, smaller than 1 but bigger than 0, a fraction, a decimal that's smaller than 1, you're going to get decay. Okay? And then last thing, you notice that the graph approaches but never got to the y value 0, right? And that's called an asymptote. A horizontal asymptote at the line y equals 0, aka the x-axis. It'll never touch that. That becomes important in calculus, something you look at and talk about with limits and whatnot. But that wraps up target 3 for us.